Okay, let's get started. Hello, everyone. Um, Welcome to our webinar. We're going to talk about risk analysis and analytics using Safran Risk. My name is Ian Nicholson. I am VP Solutions at Emerald Associates. I'm a risk analysis trainer and consultant. I started using risk analysis on cost estimates in construction projects using at risk back in 1997. I started working with schedule risk analysis as the Canadian Perp Master reseller in 2001. So I've been doing this for a while. And I started working with Safran in about 2017 when I was looking for a replacement for Primavera risk analysis for my clients. Normally joining me is Marilyn Backstrom, but she's teaching a class this week, so she won't be joining us today. So why do we conduct risk analysis? Well, risk analysis helps our project teams and executives understand and manage the risks to the project. It gets the project team discussing what the challenges will be and what they need to take action on. And hopefully, it highlights issues before they become problems. It helps us identify critical and near critical paths that might come and haunt us in the project. It's a requirement of many companies' gate approval processes. And ideally, it helps us understand the dependencies between cost and schedule. Now, I say ideally because a lot of times we can't do that. We have to run a separate cost risk analysis and schedule risk analysis, and we really want to be able to run them together. Now, I live in Alberta, and in Alberta, we have a group called the Construction Owners Association of Alberta. They meet every couple of years and talk about mega projects in our part of the world. And as far back as 2009, the COAA uh, said that project risk assessment has shown to significantly reduce project cost growth. So ask yourself, do you build detailed CPM schedules? Do you develop detailed estimates? Well, of course you do. Everybody does. But the issue is still that the chances of meeting our project's schedule and financial goals is typically a lot less than we would like it to be. Well, why is that? Well, we do detailed CPM scheduling. The problem is that the data is entered as finite values rather than ranges of uncertainty. So we say this job's going to take 4 days with 3 people working on it, and those people are going to cost us $100 an hour. Well, the problem is that those assumptions may not be valid because they change over time. Maybe they don't match reality. A lot of times, they're based on work being done in a different part of the country or a different part of the world. And then the project itself changes. The scope, the time, the conditions we're working in all can change. If we plan to start this project in the spring and we don't start it till the fall, we may be dealing with a lot of extra work due to cold weather. We do detailed estimating too. But the problem is our estimators may be too optimistic or too pessimistic, particularly if it's a bid process because they need to be aggressive to win the work. Estimators also may add their own contingency. It's the once burned, twice shy approach, where if they make contingency a line item, someone's just going to take it away. So they hide it everywhere. Estimates are built on historical experience, which again may not match what's going on the project. And they may base estimates on smaller or larger projects, and it doesn't always scale linearly from a large project to a small project. Now, these items are all what we call deterministic. So what's a deterministic number? Well, a deterministic number is a single point estimate that doesn't take any uncertainty into account. And the problem is uncertainties can build on one another to make the project very different from what we originally thought it was going to be. There's uncertainty in everything we do. The classic model is how long does it take you to drive to work every day? Well, at least when we did all drive to work every day. I mean, I could tell you that on a good day, it would take me 20 minutes to get to work, and on a bad day, it'd take me 40 minutes to get to work. And yet I do that almost every day, and I still can't tell you exactly how long it's going to take. And yet I can tell you it's going to take me 18 months to build this project in the middle of nowhere that I've never built before. Um, Now, historically, I mentioned this briefly before, we can model our cost uncertainties and we can model our schedule uncertainties, but we couldn't do them in one place. And I'm going to talk a little bit more about that as we go through, because ideally what we want to do is we want to understand the trade-offs that we can make as a project team between cost and schedule. So maybe we've got some flexibility in our schedule, but our costs are absolutely critical, or vice versa. And the project team needs to understand those trade-offs so they can make the right kind of decisions. Now, we need contingency for cost and we need contingency for schedule. And again, depending on uh, that codependency, we may find that there's a certain point in which we can give up all the money in the world, but we're not going to um, save any time on our schedule, or we can delay the project as long as we want, but we're not going to save any more money. So what we need a model that will let us understand those dependencies, and it's what we call a probabilistic model. Going back to the COAA again, another study said that on average, Alberta-based mega projects experience a 19% project cost growth and a 17% project schedule growth. We all know that cost and schedule are linked together, but we don't always understand exactly how they're linked and what those dependencies are. So what we need to be able to model our costs and our schedules more accurately. We need to limit our financial exposure. We need reproducible results. So we need a standard methodology and an audit trail that we can use from project to project to project. So we're making sure that when we look at projects, we're comparing apples to apples. We want improved likelihood of project success. We want the confidence that our results are going to be good. We want to get buy-in from the team members. We want our team members to be comfortable that the project is going well and that they will actually get useful outputs from the risk models that we build. We want to increase the maturity in conducting risk analysis, so it goes from being a one-of to being something we do every time. And we want to store everything in a common database so that we can always go back and look at it rather than have a bunch of files hidden all over our network. So the solution that I'm going to present to you today is Safran Risk Analysis. Safran has some great features. It lets us do input uncertainty and risk events. It lets us model our costs with our schedule. And by the way, this has been identified by AACE and PMI as a best practice, that your costs and schedule risk models are built together. It also lets us build things like logic uncertainty into our model. So maybe we're going to fail a test and have to do some rework or things like that. And ultimately, it lets us understand the probability of achieving our end dates and costs. It helps us understand the key drivers and their effects. It helps us run different scenarios to see what happens if we can maybe get rid of some risks or reduce some uncertainties. And that helps us develop our mitigation strategies. All right, so let's dive in. I'm going to share my screen here. All right, I'm going to start with the end. And the reason I'm going to do that is I could dive right in and start working with the tool, but what a lot of people have told me is that they're trying to understand the value of risk analysis generally. So I'm going to start with the end here, and I'm going to talk about the outputs that we get from Safran Risk Analysis. Then I'm going to loop back and show how we build the model. So first of all, this is the output of a schedule risk analysis. Um, this histogram has a bunch of very interesting information on it. What it tells me is that in this case, we did 10,000 iterations of this schedule. And these bars represent the number of times that any particular date, move this out of the way, any particular date came up in those iterations. So for example, if I look at this one of June 1st, it came up about 500 times out of 10,000 iterations. Now, if we add all of these up, we get a curve, which is this curve that goes up here, and it represents the earliest possible value we received to the latest possible value that we received. So it goes from what percentage of iterations have been accounted for. So in this case, it starts at 0, and you can see it builds up to 20%, 30%, and it slowly builds all the way up to 100% of our iterations. So what it tells me is the earliest date that we got in our model was September 11th. The latest that we got was the following year in December 28th. So our overall range in here went about a year and 3 months from our earliest outcome to our latest outcome. Now, if I want an 80% confidence level, so in other words, I want understand where 80% of the iterations uh, were completed by. So in other words, if I choose my P80 value here, it's saying that 80% of my iterations finished on or before this particular date, which was the 19th of March. Okay. Now the system will also tell me, because I've chosen that P80 value, it will also tell me that here's my deterministic value that came from my schedule, and that one came up as October 21st. So it's telling me the difference between my deterministic finish and my P80 confidence level was about 150 days. So if I want to get to that 150 day so I want to get to that P80 confidence level, I'm going to need about 150 days of contingency on my overall project. Now I can of course drill down to any particular part of the contract, or sorry, the schedule. I can choose a particular activity or a WBS element, or again, I can choose the whole project. So I can also figure out where I need to put my contingency. So I need 150 days of contingency overall, but on the fabrication section, I only need 71 days of contingency. So I can see that as well. Now, the system will also do this from a cost perspective. So similarly, the system will tell me that my deterministic cost, which was $8.4 million, was about 16% likely to occur. So in other words, in 16% of the simulations, my project cost the deterministic value or less than the deterministic value. And again, if I want to get up to my P80 value, I need about $9.1 million, which gives me about $715,000 of contingency requirement to get between my deterministic value and my P80 value. So the system is doing this. It's basically saying, okay, here's where you're at on your schedule side. Here's where you're at on the cost side. Now, the system will also let me um, look very quickly at the tornado plots to understand what are the things that are driving my project. So a tornado plot basically tells you these are the things that have the biggest impact on your project. Again, from a schedule or from a cost perspective, I can see what's really driving this. So if I want to do better, if I want to reduce the amount of time and money that I need to get to that P80 confidence level, I'll start at the top of the tornado and I'll look at this risk first. Then I'll look at the next risk, then the next risk after that. Now, you'll notice that when I look at these risks, they are all coming up with a correlation factor. So it says that the biggest impact on my overall project is the ash cloud, which has a correlation of 0.6, followed by testing overrun, which has a correlation of 0.44. Now, the project team will immediately say, well, what does that mean? What's 0.6 versus 0.4? Well, I mean, the glib answer is, well, the ash cloud's having, about a 40% bigger impact than the testing overrun. But that's not really going to satisfy our project team. The project team wants to know, how many days is this costing me on my overall schedule? Now, in older tools like Primavera Risk Analysis, I could go and turn that risk off and rerun the model, but then the next one would come up and people would want to know what the impact of that risk was, and et cetera, et cetera. And pretty soon I'd be spending a week turning risks on and off and rerunning the model. So Safran actually lets me do that automatically. So Safran will actually let me run the model, turning each risk off one at a time, and then let me know exactly how much impact a particular risk is having. So again, when I go to the project team to talk about what's happening with my model and how are these risks impacting the cost or schedule model, the tool will tell me in terms of days or dollars what kind of impact we're having. Now this is requiring it to do a whole bunch of runs of the model. So it's taking a couple minutes to run through. Remember, I've got this set for 10,000 iterations, so it takes a little longer than it would take if I had less. But what it's saying is now at a P80 confidence level, that ash cloud is actually costing me 41 days of my schedule. So again, if I go back and say, well, I needed about 150 days of contingency, 41 days of that is coming from this one risk. So it's giving me a pretty good idea of where I need to put my efforts. The next one, poor flying conditions, is 37 days. Testing overrun is 33 days. So again, it's helping me understand exactly what's going on from the schedule side. And again, I can look at it on the cost side as well. I can say, okay, my design specification risk is costing me $167,000. My transportation delay is costing me $138,000. So the idea here is that, I can go back to the project team and I can say to them, look, this is what this risk is costing you. How much effort do you want to put into getting rid of this particular risk when this is what it's costing you um, in the simulations? Now, one more thing before we go back to the beginning is because I'm running the cost model and the schedule model together, I have the ability to look at what's the probability of being on time and on budget on this particular project. Now, this is what we call our JCL, our joint confidence level. So a project that's on time but over budget is not a successful project. Similarly, a project that's on budget but's late is not a successful project either. So we want to know how much contingency do we need to actually be 80% confident that we're going to be on time and on budget. Well, that's a little bit of a different question. And to do that, we use this scatter plot. Now, each of these dots represents one simulation where we ended up with on the cost and schedule um, curve. So essentially, there's 10,000 dots on this scatter plot because I ran 10,000 iterations. Now, the first thing it tells me is that my deterministic cost and schedule values, um, represents this point right here, we're about 2% likely. So in other words, in that lower left quadrant, 2% of the dots appear out of my 10,000. So basically what the simulation is telling me is although I had a 16% chance of being on meeting my cost and about a 7% chance of meeting my schedule, I only have a 2% chance of achieving both. Now, what I want is an 80% confidence level. So the 80% confidence level is where this band changes from orange to red. So you can see here that the orange band represents my 70 to 80% confidence level, and the red band represents 80 to 100. So if I look at this point where the two of them come together, you see there's a curve here, and this is what we call our joint confidence level. So any of the points on this curve would give us an 80% probability of being on time and on budget, except that in one case, we're trading time for money, and on the other case, we're trading money for time. So the project team can say, okay, here's where we want to be. So is cost more important than schedule? If so, I'm going to go down and to the right. If schedule is more important than cost, I'm going to go up and to the left. But at some point, you can see the line goes vertical. And that means I can spend any amount of money and I'm not going to save any time. Similarly, if I go the other way, I get to a point where the line goes horizontal. And what that's saying is I can give up as much time as I want. I'm not going to save any more money. But in between those inflection points where it goes horizontal and vertical, there's a curve. And any point on that curve will give me a JCL of 80%. So the project team now can decide what their contingencies for cost and schedule need to be in order to achieve that joint confidence level of 80%. And now people often call this curve here the JCL necklace because it's like a pearl necklace with all of these points on it. And again, the project team can decide what's the optimal point for them to be at. By the way, if you have any questions, please feel free to put them in the chat or in the question section. I will come back to them at the end of the presentation. All right, so that's really cool. That really helps our project team understand what's going on our project. But how do we get there? What do we do? How do we build this thing so we can confidently put this in front of our project team? Well, let's go back to the beginning. So first of all, you'll notice there's a bunch of tabs across the top of Safran. Now, the tabs to the left of the green Analyze tab represent inputs. The tabs to the right of the Analyze represent outputs. So essentially, um, I can start at the left and I can just work through each of these tabs as I build my model. So it's a workflow based approach, which actually makes it a lot easier for people to make sure that they don't miss anything. So I'm going to start with the first tab, which is the home tab. And here, what I can do is I can import a project from P6. I can import a project from Microsoft Project. I can import a Safran project. Um, I've got a list of recent projects that I worked on in this particular database, and this sits on a SQL Server database. So all your data is kept in one place, and it can be on a network or it can be locally installed. In my case, it's on my local machine. Um, I'm going to open up this UAV prototype project. Now, when I open up a project, the first thing it does is it takes me to the Gantt chart. Now, Safran Risk is built on Safran Project, which is equivalent to P6 in terms of its capabilities. So just like I would have in P6, I can have filters and I can change my layouts and I can change my grouping and sorting and all the rest of it so that I can actually work with the schedule that I'm doing risk analysis on as I go. So if I talk to the project team and they realize there's a mistake, I don't necessarily have to go all the way back to Primavera or Microsoft Project and make the change and then bring it back in. What I can do is I can just fix it here. Um, the other thing that's really nice about that is if I do turn a filter on, for example, if I were to say I only want to see design activities, as I work through the rest of the tabs, the filtering, grouping, and sorting that I've defined in the schedule tab will carry through to all the subsequent tabs. So if I have a very large schedule, but I'm only doing risk analysis, say on the engineering part of the schedule, or I just want to work with the engineering part of the schedule, for example, I can filter this down and just do the work on that part. I don't need to work with the whole massive schedule all the time. So I can just turn that off so I see everything again. Now, once I've got the schedule in here, I can move to a tab. It'll show me any issues with the schedule. So the system's going to tell me, hey, you know what? You've got problems with these particular activities. Maybe there's open ends or there's lags or there's constraints or anything like that. And I can fix them very quickly. If I want to go to a particular problem, in this case, there's a lag on there, I can just right click and say, go to that activity. It'll take me there. I can fix the problem and I go back. It will disappear from the list. So the list is constantly being updated each time I work through. And I can configure what things it looks for. So I can tell it what kind of things I want to check for. Now, the next thing I'm going to do is I'm going to define what are the risks to my project. So in older tools like Primavera Risk Analysis, for example, um, there was a risk register, but it was only useful for risk events. You didn't have the ability to put risk factors or uncertainties in there. They could only be risk events. But in Safran, all of your risks can go here. And the idea is that I can put just general uncertainties. I can put risk events. I can put branching, like logic branching. I can put existence in there. Basically, all of those things come back to this one module. So I'm going to put all of my risks in one place. Now, if I take a particular risk, in this case, I've got this risk for the flight corridor is closed due to an ash cloud. So it's saying there's a 40% chance that that's going to happen. If it happens, it's going to have a schedule impact, and here's what the schedule impact is going to look like. Now, an impact can be relative, which means it's a percentage of the deterministic value, or it can be absolute. So I can change it to say if this risk fires, it's going to have an impact of 10 days and $50,000. Or I can make it relative and say it's some percentage of the original value. I can define whether it has a schedule impact or a cost impact or both. In this case, it has both. I can also define a pre-mitigated position, which basically means my original position, but I can also define a post-mitigated position. Now, the advantage of this is I can say, okay, we're going to execute some mitigation strategies, and those mitigation strategies are going to reduce the impact of this risk. So when we talk about mitigation strategies, we can avoid the risk, we can reduce the risk, we can transfer the risk to somebody else, or we can just accept that the risk is what it is and there's nothing we can do about it. But by going in here, I can define what my action plan is to manage this particular risk, and then I can define what the impact of that risk is going to be after my mitigation strategy is complete. Now, once I've defined all of my risks, then what I can do is I map those risks to the activities in my schedule. And I'll come back in just a moment to show how they map to the cost side. But the idea here is that when I take a particular activity, in this case, I've taken design the GPS system, um, and when I look at my schedule impact, I can see that, let me scroll down a little bit so we can actually get it highlighted. There it is. Okay, so I can see here's the risks that I have associated with this particular activity. And the system will tell me, here's what the overall impact of those risks looks like on that activity. Now, this is really powerful because I can have as many risks as I need to on a particular activity, and I can see what the impact is going to be. The system does a little mini Monte Carlo analysis to come up with this distribution shape, and it helps me identify a risk that's maybe out of scale for the activity. So if I have an activity that's, say 20 days, and I have a risk that's 3 years, if it fires, that's probably not appropriate, right? It's unlikely that a 20-day activity is going to turn into 3 years. And I'll see that immediately because as soon as I assign the risk, this shape will get pushed way over to the right, and I'll see that there's a problem. So this kind of helps me figure out my risk mapping issues before I go any further. So it's very useful from that perspective. Now, if I were to add another risk, so for example, if I was to go and for example, say choose my let's see, procurement delays, for example, it will add that to the list and then it will redraw the graph immediately to show me what the impact of that new risk is going to look like. So again, as I'm building these things, I can immediately see what it's going to look like with that additional risk applied. Okay, so again, very powerful when I'm actually building this. Now, once I've associated all of my risks to all of my activities, then I'm pretty much ready to run the analysis. But before I do that, let's look at the cost side. So we're going to go to the cost tab, and this is where we build our cost model. So let me just expand this so we can see it. Now, the idea here is I have a cost model that I want to build. Now, some of those costs are going to be schedule related, and some of those costs are not going to be schedule related. So for example, if I have materials I need to buy, purchasing the materials does have risk, right? So we all know what the global supply chain is in trouble right now, and it's difficult to get things, and there's big delays and everything. But once I actually have it in my hands, the cost doesn't really change with the schedule. So what I could say is that my materials are probably not really schedule related, but my labor probably is schedule related. So if it takes longer to install it and I've got the crew out there working on it, it's going to cost me more money. But the material I already purchased is just going to sit there waiting for them. So although there's some opportunity cost and things like that, it's not really a schedule driven cost. Well, when I used to want to build an integrated cost and schedule model in a tool like Primavera Risk Analysis, um, I would have to build a resource loaded schedule that picked up all of the costs associated with the project, which meant there was a whole bunch of costs that weren't schedule related that I had to park in the schedule somehow anyway. So that was really difficult, and really it was just a lot of work for not much benefit. So with Safran, what I can do is I can build my entire cost risk model in this spreadsheet view, and then I can decide which of my items are schedule related. So I'm just going to turn off a couple columns so we can see a little better here on my smaller screen. Let's turn off those. So first of all, in this case, I can build I can build my cost model, and in this case, I've defined there's a base cost, there's a base quantity, there's an exchange rate involved. So for example, if I look at this line item for transportation, it's going to cost me $120,000 for each of my shipments, right? Now I've defined an uncertainty there where it could be as little as 98,000 or as much as 185,000. I expect I'm going to need 3 shipments, but maybe I'm going to need as few as 2 or as many as 6. So I've defined a quantity of shipments and an uncertainty around how many of those shipments I'm going to need. And I've also put an exchange rate uncertainty in there. So I've said I'm expecting the exchange rate to be 1, maybe it's US dollars to euros, for example. But it could range from 0.95 to 1.35. So I can define that uncertainty as well. So when I run the actual cost model, what the system is going to do is for each iteration, it's going to take all of that into consideration to come up with a cost for this particular line item. Now, in addition, I can also assign my cost risks to any of my line items. So narrow this up a little bit. So for example, down here on this test site cost line item, I've assigned a couple of risks. So I've said, okay, this one the design risk is going to impact this and the ash cloud is going to impact this. Now, any of the risks that I assigned in the project risks tab that have costs associated with them are available here for me to choose and assign to any of my cost line items. So now these have a probability of occurrence. If they do occur, they have a cost associated with them, and that's going to be taken into account in my model. Now, what about those items that are dependent on schedule? So I mentioned a lot of those are going to be things like labor cost. They're going to be my fixed cost, like my site costs, my project manager costs, things like that. Um, well, those items I can link to the schedule. Now, the way I do that, I'm going to go back over here and turn on these schedule columns again. The way that I do that is I can take, for example, let's say my testing resources, and what I can have the system do is I can choose an activity from the schedule or multiple activities from the schedule, and I can say what percentage of this cost line item is linked to the schedule. So in this case, I said it's 50%. Now, what does the system do with that? Well, what it does is it says, okay, you've got this $310,000 line item. Now, that's going to change with each iteration, of course, because depending on what my uncertainties and risks are, that number could change. But right now, my deterministic value is $310,000. It's 50% associated with this particular schedule line item. So what that says is $155,000 is fixed, i.e. it's not linked to the schedule, and $155,000 is linked to the schedule, and therefore it's linked to a 40-day activity, which means that my day rate is $3,800 per day. So $155,000 spread over 40 days, $3,875 per day. Now, if that activity goes shorter, the cost overall is going to go down. If the activity goes long, the cost is going to go up. So that's how I'm going to link those cost items to the schedule. Now, the beauty of this, as I said before, is anything that's not schedule related, I don't have to try and find a place to put it in the schedule. I can just leave it alone. So I don't have to link everything between cost and schedule, only the things that are appropriate. Okay, so once I've done that, now I can also define, if I want to, any correlations that I have. Now, correlations can be between the probability, the schedule, the cost. All of those things are available for me to correlate together. So what I can do is say, okay, if this risk happens, like for example, if the risk for a poor soils report fires, then the risk for poor productivity from my piling crew is more likely to occur because they've got poor information that they're working off of. So I can say if one risk fires, another risk is likely to fire. I can also say that the impact of a risk is likely to be correlated. In other words, if I've got this risk on many activities, do I want the risk to have the same impact on every activity or a different impact on each activity? And I can define that as well. Now, once I've filled all that in, I can go to the Analyze tab. And in the Analyze tab, what I can do is I can tell the system what I want to do when I'm running the risk analysis. Now, keep in mind that every iteration of the model has a cost iteration and a schedule iteration. So it's running both models at the same time, which gives us our scatter plot at the end, right? So on each iteration, some risks will fire, other risks will not fire. We rarely end up with a situation where everything all happens in the best case or worst case scenario. So that's what we're trying to model with a Monte Carlo analysis. Now, when I do the analysis, I can tell the system that I want to exclude some risks simply by turning them off. I can also tell the system that I want to run some risks in the pre-mitigated position and some other risks in a post-mitigated position, which allows me to do a lot of analysis around what happens if I can mitigate these particular risks. So maybe I've got a mitigation strategy for some of my risks. For example, the ash cloud was the biggest impact we saw in the tornado chart earlier. So I probably want to have a mitigation strategy for that. So I can run that in the post mitigated position. So this is a big advantage because I can mix and match. And again, going back to Primavera risk analysis, I could only run everything in a pre-mitigated position or in a post-mitigated position. But here I can mix and match as I feel is appropriate. I can also tell the system how many iterations I want to run. And right now I'm running 10,000 iterations. The system is pretty fast, so I can run more iterations than maybe I would in an older tool. I can also include or exclude correlation. I can use Latin hypercube sampling or Monte Carlo sampling. I can resource level after each iteration if I have a resource leveled schedule in Primavera or Microsoft Project. And I can also step through the analysis. So I'm going to turn on the step through. The other things that I can do is I can define focus activities and focus costs. Now, why would I want to do that? Well, a lot of times when you're doing risk analysis, there's a bunch of costs and or schedule items that you don't really care about in the analysis. For example, in the schedule, I don't really care about demobilization activities and site cleanup activities and all that kind of stuff. What I care about is, when is this thing going to be turned over? Like when is that transfer of care, custody, and control date going to be? So what I can do is I can choose that particular activity that I really care about, and we call it a focus activity. So maybe what I can do is I can say, okay, what I really care about is, when is the testing going to start? So I'm going to choose this guy here, for example, and say okay. And similarly, on a cost side, I can select a particular cost I'm interested in. So maybe I really care about a particular cost element, so I can choose that as well. And the idea here is I can do further analysis on these once I make them focus costs and focus activities. So I'm going to run the analysis now. Now, as I step through the analysis, it takes me to the Gantt chart, and you can see as I step through the changes in the schedule as we run each of these. So you can see it's moving around based on the risks that we've defined. Now, similarly, on the cost side, if I go to the cost tab and I scroll over to the right here, so I see my final iteration value. You can see right now it's 8.3 million in this iteration. Next iteration is 8.5, 9.3. And by the way, as it runs, each of these risks lights up to show you when it's actually firing. So as I step through, you can see they turn on and turn off because there's only some percentage of the time that each of them fires. So I can see exactly what's happening as I go through my model by doing this step. And again, as I said, you can do this on the schedule side, you can do it on the cost side. Keep in mind that it's running one iteration of each time, and the interdependencies are being considered. Now, when I've seen that enough, I've done, and I'm comfortable everything's working properly, I can just hit complete, and it'll do the remainder of the 10,000 iterations. And it takes me back to that distribution graph, which is where we started. Now, a couple of other things that I can do here. When I'm looking at my distribution graph, I'm looking at it now on the schedule side. I can look at it with my focus activities. So here's where I can actually bring in my focus activities and focus cost, and I can see what's going on there. I can also look at it from a data view perspective, which is useful because it will tell me for each iteration of those 10,000 iterations, which risks fired, and did they have a positive or negative impact, both on my cost and on my schedule. So in this case, on this first one here, let's turn off the focus activities. We'll look at the overall schedule again. So on my first iteration, we went to 842 days. Here's the risks that fired. Now you notice that some of them are kind of washed out pink color and some are quite bright red. That's showing you where they were, what kind of impact they have. Did they have a weak negative impact or a strong negative impact? And it will go green if they had a weak to, to strong positive impact as well. So you can see that some of these are in green and some of them are in red. So in this case, on this iteration, this particular risk had a positive impact in the schedule. Impact reduced our duration to 86% of the original value. Now, I can actually sort this to say what was the shortest overall duration, which was 549 days. Here's the risks it fired. You can see they're mostly positive. And I can even go to that iteration, and it will show me what the Gantt chart looked like in that particular iteration. So if something looks really wacky, I can actually go to that iteration and understand what was going on. And I go back to my distribution graph, go back to my regular view. And of course, I can configure any of these as well. So if I don't care about P80, I really care about P70, I can use that value. I can change how everything's displayed and everything on the screen as well. Now, because again, we're doing our joint cost and schedule. So again, we've got our scatter plot, which gives us our overall results here, and we can kind of see where we ended up. We can also do a probabilistic cash flow. Now, the probabilistic cash flow will show us where we actually ended up uh, spending the money in terms of time. Because again, we've got this cost model and we've got a schedule model. Now we can build the time scales in to show when the money's likely to be spent. Now, this is really useful if you're working on a project where you're getting funding on an annual basis. So I've got a number of clients who do government work, and in that case, it's just as important to them to not underspend as it is to not overspend, because they have a certain budget every year, and if they don't use it, they lose it. So in that example, they really care about how the money's being spent, but also when the money's being spent. So let me just turn a couple of these off to clean this up a little bit, make it a little easier to see. So we'll take our P80 values again. Okay, so now what the what the system is showing us is when are we actually going to be spending the money on this particular, actually I need to go here. I need to click on the cost to actually see it. So give me 1 second. It's going to calculate. There we go. Okay, so now what it's saying is, here's what my deterministic cash flow looked like. That's the black line, my deterministic. And here's what the probabilistic or at cash flow looked like at P80. So you can see at this point here, we end up overspending. Then at some point we had a big spend here on the deterministic side, which meant that we had actually caught and passed us, but then we caught up again. And at the end of the day, here's where we ended up. I can also turn the scatter plot off just to make it a little easier to see. So ultimately, here's where we finished on our deterministic cost and schedule. Here's where we ended up finishing on our probabilistic at a P80 value. So again, we can kind of figure out how we're spending the money over time as well. Now, the other thing that we can do here is that I mentioned before that we could turn things on and off to run scenarios. Well, we have a distribution comparison feature here as well. And what that will do is it will let us compare different scenarios. So when I run a scenario, what I can do is I can copy it to the comparison, and then I can lay them over top of each other and see how things change over time. So for example, if I just turn a couple of these off, okay, so if I just look at these two, I can see how my overall distribution changed between two different scenarios. So again, at my P80 confidence level, I can see the difference between them. You can see it's fairly small, but you can see the variance there. There's a bit of a variance, probably about, about 3 or 4 days between these two different scenarios. So again, when I'm doing that kind of analysis and I'm trying to understand, if are my mitigation strategies working? Are they effective? I can very quickly see exactly um, what they look like by overlaying one on top of the other. Okay, so that's Safran Risk in a nutshell. It's a very high level overview of the software. Um, so just to go back to my slides here for a moment, and then we'll open it up for questions. Okay, so we have clients all over the world using this tool. A lot of them are our clients, and a lot of them are clients that Safran itself has that are listed here. Um, Safran has become very successful because they have this ability to do joint cost and schedule. And the other thing is, I didn't mention this before, is Safran was developed by the same people who originally developed the PertMaster tool. So what they did was they went back and said, okay, if we were doing this all again, what would we do differently from PertMaster, which became Primavera Risk Analysis? And I think you can see when you look at the tool, things like the way the workflows work and the way things are entered makes it a much easier process than it is working with older tools. So they basically fixed all the things that made the old tools difficult to work with. Okay, at this point, I'll open it up to any questions that anybody may have. Okay, so the first question is somebody says, well, how can we have it? How much would it cost? If you want to reach out to me, I'd be happy to talk to you about the pricing of the tool. I'll put my contact information up in just a minute. Um, Someone else asked, how is the licensing type? So the the licensing is a user-based license. You can purchase an annual license or you can purchase a perpetual license. It is a client server application, but it can be hosted as well if that's what you need. In most cases, what our clients are doing is they're running it on a standalone computer, like I'm doing on my computer here. Um, Now, is the connection method, as I mentioned, it is a desktop client. There is discussion about putting it into a web-based client, but it's early days for that. Um, can we integrate the P6 schedule besides import export? There's no direct connection between P6 and Safran, although as I mentioned, the development team did work for PertMaster, and PertMaster had a link that would pull from Primavera. Safran right now just works through import export. However, you do have the ability in the tool to actually import and export from Excel into any of the risk modules. So you can also import from, if you've got a risk register tool that you use, you can use Excel to import that data in for your risks and your risk mappings and all that sort of thing as well. Um, are there any limitations on Primavera P6 versions? No, there's not. So again, the integration is through XCRs. So the Primavera XCRs haven't changed, although Primavera will kick back if you try and use an XCR from a newer version. But in reality, the XCRs are never really changed all the way back to version 7, maybe even earlier. So in that case, it works fairly seamlessly, but you don't access through web services. So it's only accessible through XCRs. Next question. Uh, can we still map risks with activities in P6 risk analysis? Um, I'm not sure if that's a question. You can map in P6 OPRA, Primavera Risk Analysis, you can map risks to activities similar to what we saw here, but only risk events, right? So your uncertainties, you have to apply directly to the activities, which means you have to either put them on manually or you have to use the quick risk functions. Um, can Safran risk be integrated with ERPs or other cost control tools, for example, Ecosys or Unifier, to perform cost impact analysis in addition to the P6 cost loaded schedule? Yeah, absolutely. So that cost module that we talked about, let me just go back to my screen for a second here. So if we go back to the cost module, you don't need to even use a schedule if you don't want to. So one of the things that comes up in after these um, sessions we often talk about is we talk about integrated cost and schedule risk analysis, but there's nothing to stop you doing only schedule or only cost risk analysis, or do them separately and then combine them together at some point down the road. So I can build my entire cost model, I can build my entire schedule model, and then pull them together at the last moment, or even just run them completely separately if you want to. So this cost module can all be imported. So for example, let's say you're using Ecosys or SAP in your examples. Well, I can take my cost model, I can dump it out to Excel, and I can import from Excel. So in this case, the import export works really well with Excel. So Excel can be used to take your cost model from whatever tool you're working in, put it into Excel, bring it in here, and then build your model. Now, you can also then do all the mappings and all the uncertainties and everything with Excel as well. So it actually makes it very easy when you're working within these tools, because virtually anything will work with Excel. Okay, looks like those are all the questions we have right now. If there's any other questions, feel free to put them up. I'm just going to stop sharing my screen again for a second. Okay, so my contact information is up on the screen. For those of you who've asked about pricing, feel free to reach out to me. I'd be happy to discuss pricing with you. I think some of you were sent here um, by Steve Hunt as well. If you're already talking to Stephen, then you can continue to talk to him about pricing. Um, the tool is quite a bit cheaper than Primavera Risk Analysis, which is kind of a pleasant surprise for a lot of people. Um, so it's certainly competitive in terms of its price. But again, feel free to reach out to me either by email or by phone, and I'd be happy to discuss pricing with you. The model is named user. There is a concurrent user license available. It's quite expensive, but for some business cases, it makes sense. So, for example, if you have, you know, 5 people or 25 people, all who use the system very occasionally, then it might make sense to buy a 5 user concurrent package. But if you have power users who do a lot of risk analysis, you probably want to get them their own dedicated license. So you do have that kind of ability in there. There was one more question here. How are the results of the analysis integrated back to the schedule? So you can export from here to an XCR as well. You can store the results of the analysis in user defined fields, and then you can use those in P6. So for example, if you wanted to create a probabilistic Gantt chart in P6 based on user defined fields, you could do that um, by building them into the XCR that goes back to P6. So you have that capability as well. Okay, so with that, it's okay. So another question just popped up. So the actions, the mitigations for post, can these be imported as well with the risk register? Yes. So actually, when I go to my project risks, everything here it works through the import export. So what it does, it creates a bunch of tabs in the Excel file, which actually represents the risks, the impacts, and then also the actions that you're taking to get to your post mitigated strategy. All of that ends up in that spreadsheet. So so absolutely, you can import that and export that through Excel if you want to. They've tried to make the system very open in terms of how it works with Excel, which I think is huge, because it just makes everything so much easier when you're working with another system, rather than them building a whole bunch of point-to-point integrations. Um, They are working on some micro web services so that you can pull information from Safran Risk, but those are still a little ways off. All right, so it is 26 after. We'll wrap it up now. As I mentioned, please feel free to reach out to me or Stephen Hunt, and we'll be happy to talk to you about um, about Safran in greater detail. If you have very specific questions about your use case, let us know. We'll be happy to work through it with you. Thank you very much.